Hey, I have another thing that I'm really excited about for our future, and that is quantum computing. Now, this is something I admittedly know very, very little about compared to maybe someone who is working in a quantum computing lab or is really, really in depth in it. And all I get to read is articles and research about how it works and the inner workings of quantum computing, a lot of theoretical knowledge, instead of the practical purposes of things that are actually happening right now. So I want to preface this. If I say anything that is wrong, incorrect, that is just me as a novice and as like a kind of a fanboy of quantum computing, please correct me. And I want to learn all the details here. I just don't have that many people that I can talk about quantum computing with. I don't know anyone that works in the industry. I've just been really excited about all the cool advances that we're seeing right now. Recently, probably the biggest news has been Google came out with their Willow chip, and this happened in like early December. So now, when I'm making this video about a month ago, a little more than a month ago, this chip, the main uh the, they this is a huge article that says like, wow, we have cracked the code on quantum computing, and they just kind of touch on this one fact that compared to one of the world's fastest supercomputers, so not like an average like MacBook, like this is a bajillion-dollar computer in some big data center that is a CPU. It is it ran a task, this benchmark test, in 5 minutes, but it would take the world's fastest supercomputer, one of the world's fastest supercomputers, it would take it 10 septillion years to process. So I want to put that in perspective. A septillion is a number you probably haven't heard of because it is so big. It has 25 zeros. Now, if you were to convert this to minutes, because of 5 minutes to years, you're looking at 10 to the 28th. Now, to put this in perspective on how large that is, it is incomprehensible. I mean, the universe is only like 13.8 billion years. So, I mean, this is not even close to the amount of time in the universe that has gone by. This would be like, imagine 5 minutes is the size of a golf ball. And I ask people all the time, like, hey, what what would you think that if 5 minutes is the size of a golf ball, how big would 10 to the 28th be? And people say, oh, the size of the earth. I'm like, no, way bigger. The size of the sun? No, we're not even close. It would be roughly the size of the observable universe. It is unbelievable. And so to put that in perspective, light that takes 100 million years to get to us, that is how far this is, like, compared to a golf ball. So this is uncomprehendibly fast, and it can only be used for like certain types of computing power. Uh, but it happens to be, just happens, by our luck, that one thing that it can be used for is one, breaking encryption, and I'm gonna explain why, and the other would be AI, and this is because it does like linear algebra really well. So first off, let me explain why it would break computing or like our encryption so fast. One of the main ways that encryption is done is like RSA encryption. That it's like the kind of the backbones of SSLs. Which, if you ever go to a website and you see HTTPS in the browser, this little green thing in the thing saying, "Oh, we're secure." How that works behind the scenes, and this is how it's been done since like the '60s, is they take two prime numbers and multiply them together to get a big number. And so like the example would be like a prime number like a 5 and an 11. They multiply that to get 55. Well, computers are able to figure out, for one, is a number prime. That they can figure that out instantly. And then two, they can figure out how to multiply those to get something that's like instant. And they can figure out if these numbers match. But when you have very large primes, and I'm talking like a number with 100 zeros or 100 digits, so like a random number, seemingly random, but it is prime. There are like millions of primes. And they would take these numbers, evaluate if it's prime, and they take two of them, multiply them together. And this is how they get a secret. So like the two primes are your secret, and they get their prime. And theoretically, this can be figured out, but it takes like forever to figure this out, to brute force this. The computers, like a CPU or even a GPU, is unable to do this. But where a quantum computer comes in is it's able to do a bunch of calculations really, really fast. So we can zoom through all of these numbers instantly and figure out a number and figure out the answer just by brute forcing it. So it can say, does 1 times 1 equal this? Does 1 times 2 equals this? Et cetera, et cetera, et cetera. And it can go through the whole list, figure out which one works, get the key, do it instantly, and now our encryption is like seemingly useless against this. And so that's why you're seeing a lot of like quantum computing stocks take off that have to do with encryption, because like this might be a thing soon, and we're going to need new encryption, like it's like quite obviously. And the other thing is, like as I said, you have this ability of doing multiple calculations at once. So imagine linear algebra, and this happens with GPUs. This is why GPUs are so big with AI, is it's doing linear algebra. And I want you to imagine like you would have a spreadsheet of information. This is like linear algebra. You're doing all these tiny little calculations, one by one, one by one. And they're relatively simple, like adding or multiplying some like numbers, very simple math, but a lot of them. And in this like in a quantum world, you can do so many more instantly. Now, if you were to graph this on a chart, like if you're like kind of a nerd and like to graph things like me, a CPU would be like n, which would be just like a straight line, whereas GPU would be like n squared, which would be like this. And so you think of that as like a kind of a grid. That's why GPUs are really good for gaming, because they have to calculate each pixel all at the same time. Whereas GP, or as quantum computing goes, you have 2 to the nth. And so if you were to graph that, it would be a straight line up. Like you wouldn't even see it on the graph because it grows so fast. So that means like for every like bit of information, you are adding an exponent to this. So it would be 2 to the first, 2 to the second, 2 to the third, 2 to the fourth, 2 to the fifth, etc. This is going to go up, straight up in the computing power. So the bigger the application on the computing, the more powerful the quantum computer is, at least based off of this. And this is because the inner workings of quantum computing, you have to look at the qubits, which have, well, you can have a 0, you can have a 1, like in standard computing. But you can also have this ability of being in both places at the same time. And this is where like the parallel universes come in, and it splits off, which this is like very theoretical but proven, which is crazy. And you have this ability of now having it can divert and come up with every possible like permutation in a calculation all at once, and do incredible math like instantly. This is going to mean that our models that right now are AI models, This is like why I'm excited about it for like my life and also for everyone else's with the power of AI and how valuable this is. Like right now, a model takes a data center that is like 30,000 GPUs. Like, I mean, it's like these crazy expensive billions of dollars are being poured into GPUs with NVIDIA chips. They're so large and they are going at this in such a way that it takes so many computers. You just need one quantum computer to compete with all of that. And it takes these GPUs like 9 months or something ridiculous to train some of the top performing models. And that's why it takes so long for them to come out. Imagine if today's model that takes a year to come out, which by the way is incredibly fast compared to what it was a few years ago. Like, of course, because GPUs are significantly faster at doing AI computation than CPUs were. But imagine you can get that done in a minute or 10 minutes, something negligible, where we can have realistically uh, like O like 1 or O3 level model from OpenAI, the top models, available tomorrow and the next day and the next day. Imagine the level of iteration that can happen and the cycles of improvement on the base level AI that will be the foundation for tooling for everyone else. We're talking AI that would be so smart, like it would most likely be sentient. I mean, that is on any level the like artificial super intelligence, if you want to say ASI or artificial general intelligence, AGI, it would meet those standards almost like for sure. Because I mean, I think it's already meeting that. So I'm very excited about quantum computing, if you can't tell. And I don't think we need a quantum computer in our pocket. We don't need our iPhones to have this. We don't need our home computer for this to change the world. We just need a few quantum computers in the world to really change our life. We realistically maybe one. There'll be some companies like Microsoft, an OpenAI, or the U.S. government, the Chinese government, people that are working on it, and we Americans and the Chinese seem to be the top performers of the quantum research right now, at least from what I've seen. And like, please prove me wrong if you know of other countries that are really big on this. If we make improvements to this and it actually works, uh, whoever comes up with the quantum computer is like going to control the world. This ability is going to be amazing, and it's going to change our life almost in a way that we can't comprehend. I think that just the GPUs are changing our life a lot. I think quantum computing will change our life at an exponential rate that it's just going to get very weird. Very, very weird. Anyway, I'm very excited about it. If I said anything here that you think is inaccurate in any way, I would love to know. Always love an opportunity to learn. And if you just want to chat about quantum computing, I would love to talk about to someone that is knowledgeable, that has like maybe done some research. If someone works in the industry that you know of, I would love to be connected with them just to have a conversation with it. It's incredibly fascinating for me, and I think it's going to be absolutely life changing. Whether it happens in a couple years from now, if it happens in 20 years from now, no one knows. But I think it's pretty certain it's going to happen, and I'm very excited for the future. Uh, Let me know in the comments what you think.